Welcome to TDWI's webinar program. Thank you for joining us today. I'm Linda Briggs. I'm a contributing editor here at TDWI, and I'll be your moderator. Our program is entitled Marketing Analytics Meets AI, 6 Strategies for Success. Our sponsor is SAS. Leading off our presentations today, we have 2 of our TDWI research directors. Fern Helper is TDWI's Senior Director of Research for Advanced Analytics. In that capacity, she focuses on predictive analytics, social media analysis, text analytics, cloud computing, and other big data analytics approaches. Fern has more than 20 years of experience in data and business analysis and has published numerous articles on data mining and information technology. She's the co-author of Dummies books on cloud computing, hybrid cloud, service-oriented architecture and service management, and big data. Joining Fern today, our second analyst is David Stauder, who is TDWI's Senior Director of Research for Business Intelligence. As an analyst, writer, and researcher, David's provided thought leadership on key topics in BI, analytics, IT, and information management for over 2 decades. Previously, he headed up his own independent firm and served as a Vice President and Research Director with Ventana Research. With TDWI, Dave focuses on providing research-based insights and best practices for organizations implementing BI, analytics, performance management, and related technologies and methods. So on that note, let me turn things over to Dave to kick us off. Dave, over to you.
Great. Thank you very much, Linda. And thanks to everyone who's joining us today and to Fern and Wilson as well. I think we've got a good program, a lot of interesting things to talk about today, as we'll be looking at really kind of leading edge and advanced kind of thinking around marketing analytics and what people can do to improve their marketing. So let's look at the agenda for today. We're going to open up with just a few definitions so that we're all kind of on the same page of things and have an understanding of what some of the elements of what we'll be talking about are. And then Fern will be talking about marketing analytics today and talk about some of the artificial intelligence or AI components. And then we'll be going through 6 examples of how AI can be used to enhance marketing analytics. So that'll be our 6 strategies for success. So to get started, let's talk about some of the things let's define some of the things we're talking about today. And of course, the big one is marketing analytics. And so here are definitions about leveraging insight from data analysis to make marketing more efficient and effective. It involves analyzing, measuring, and optimizing marketing efforts. So some of the thinking that goes here is really a lot around driving return on investment, or ROI. So you want to make it effective. You don't want to waste customers' or prospects' time. You don't want to waste your company's marketing dollars. So it's got to be efficient. It's got to be effective. And then you need the ability to track it to see how you're doing. Can you track the customer journey through your website, for example, and see whether it's effectively leading to purchases or what you want them to do? And how do you optimize that? How do you measure it, then how do you optimize it? So those are kind of the thinking that goes into marketing analytics. So a lot of it is around sort of the daily look at what's going on, what users are doing on the website, and how you can make it better, how you can make it fit with your ROI objectives. Now, a close cousin to marketing analytics, and they really do fit together in important ways with marketing analytics, is customer analytics. So customer analytics we define as about technologies, processes, and methods for developing insight into customers' behavior, their paths to purchase, and what actions will improve their satisfaction and loyalty. And so, obviously, customer analytics is a little more wide-ranging, trying to understand what's going on in the customer's minds as they're on their journey, whether it be through your website or through other channels, and often in many ways a multi-channel perspective. And how can you do things like segmentation? How can you apply things like predictive analytics to get a better sense of what their wishes are, what their desires are, where they're going, and then begin to assemble your marketing analytics strategy based on that knowledge. So you can see how they fit together. The more you know about your customers and their behavior, what their intentions, what their preferences are, the better you can begin to align your marketing analytics. So here we have the relationship between it, allowing you to use that knowledge to deliver offers that are anticipated, relevant, and timely, which are sort of 3 key principles as they fit together. So I'm going to hand off to Fern to define artificial intelligence.
So Dave talked about marketing analytics and customer analytics and how they fit together. And we're talking about how artificial intelligence can be used with marketing analytics. And artificial intelligence includes techniques used to teach computers how to learn and reason and infer and communicate and make decisions like humans do. And there's many applications of artificial intelligence. It spans technologies that can recognize images or process human speech and perform decision-making. Those are just a few. Some everyday examples include things like personal assistants like Siri, smart homes if you get calls from the bank about your credit card being fraudulent. That could be an example of AI, smart cars, it's in video games, it's in recommendations, and more. So really it's a series of capabilities that include technologies such as machine learning and natural language processing and cognitive computing. And it's enabled by techniques such as optimization and decision management, and I'll define these terms as well. You know, AI is not new. It's been around for decades. It's been evolving for the last 50, 60, 70 years actually. But there's been a recent resurgence in interest around AI as data continues to grow in size and diversity. And the compute power actually exists to analyze the data. And you know, whether that's on premises or in the cloud, the compute power is there. So the point we're going to make here is that AI, so artificial intelligence plus marketing analytics, can have a positive impact on your organization. And we're also going to make the point that it isn't futuristic. It's actually happening today, and we'll give you some examples of that. So before I define the terms around what's machine learning, you know, what's cognitive computing, I just want to step back and talk about the fact that marketing does make use of next generation analytics today. And in fact, if you look at what's happening out there with advanced analytics, we find in our TDWI research that marketing is often one of the first departments in an organization to use more advanced analytics. This chart here comes from data for a report that we did in 2015 on next generation analytics. And in that, we define next generation as moving beyond reporting and dashboards to things like discovery, prediction, text analytics, and so on. And we asked respondents where next generation analytics was being used in their company. And here are two of the areas, marketing and/or marketing analysis, and customer service and support. The green is using now, and the blue is will be using in 3 years. And you could see that marketing and/or marketing analytics, 46% of the respondents to this survey were making use of it now, with another 32% planning to do so in the next 3 years. You know, likewise, customer service and support, because we're talking about the full customer experience, 40% of organizations were using that now, another 32% over the next few years. So marketing analytics was actually at the top of the list. There was also things like executive management analytics and sales, but marketing was at the top, and that sort of gets to this point that marketing is often one of the first parts of the business to actually use analytics. You know, here's another view on this. And this is actually from a survey on predictive analytics that we did in 2014. And here we asked what predictive analytics is being used in your company. And here the dark blue is using today, and the light gray is planning to use within the next 3 years. And you can see that these marketing-related activities, some of which are more customer focused, they're at the top of the list. You know, direct marketing, cross-sell, upsell, propensity modeling, we'll talk some about that, and retention analysis. Those are topping the list with over 50% of respondents using those techniques today, at least, you know, claiming that they were in this survey. So again, you know, sort of the close to the 50% that we were seeing in that previous slide, where we saw that more than 45% of organizations were using some sort of advanced analytics in marketing. So let's talk a few minutes about some of the enabling technologies and some of the core AI types of technologies. As I mentioned previously, some of the subcomponents of AI include things like machine learning, natural language processing, I'll call it NLP, cognitive computing, and these are being woven into the analytics arsenal in various departments and organizations across industries, one of which is marketing, as we just saw. So on this slide, I'm mentioning some of these core components. Those are in the blue. And there are also these enabling technologies for AI that include things like decision management and optimization. So let me talk briefly about each of these so that you can understand what they are when Dave and I are giving the 6 strategies for success. Okay, so the first one is machine learning. This is a really, I don't have to tell you that, how hot of a topic this is in the market. And machine learning involves building systems that can learn from data to identify patterns and predict future results with minimal human intervention. And when people talk about machine learning, they usually talk about 2 ways to do this, although there's more than this, but they talk about supervised or unsupervised methods. So let me talk about supervised machine learning because that's pretty popular. And so what happens here is that in supervised machine learning, the computer learns from examples with known outcomes. Some people call the outcomes labels or targets. So here's an example. I might want to build a churn model that predicts the probability of churn or no churn. So in this case, churn is the target or label or outcome, as well as no churn. So what I do is I feed the machine a bunch of examples with known outcomes, and these examples have attributes associated with them, and so that the computer or the machine can actually learn the patterns that predict churn or no churn. And so those attributes might be the products that the customer bought, the length of time they're a customer, where they live, how old they are, and so on and so on. There can be thousands of attributes. And so I have those attributes. I know the known outcomes. I supervise the learning system because I'm feeding it that data. And the system learns from the training data that I give it to come up with some rules or some ways of thinking, if you do this and this and this, then maybe, that's your outcome. And so it's learning, and then I might give it some test data to see how well it does on new data. So a simple example of a machine learning algorithm is a decision tree. And there's lots of different approaches to machine learning. There's also unsupervised approaches where I don't give it a target or outcome variable of interest. And what's interesting to me is that people talk about machine learning like it's separate from predictive analytics. And the reality is that machine learning algorithms are often used for predictive analytics. It's just that the machine learning algorithms are a computationally based math approach rather than a statistical approach. So there's different ways to get at sort of the same thing. And so Dave and I will give you some examples, and Wilson will also talk more about this. Then there's natural language processing. So remember I was telling you there were a couple of components of AI that we're going to talk about. So machine learning, now natural language processing, NLP. And what NLP involves is analyzing and understanding and generating languages to ultimately enable interfacing with systems using human language rather than computer languages. So for text, NLP often uses semantics to parse sentences to understand and extract things like entities, which are people, places, and things, as well as concepts, which are words and phrases that indicate a particular idea, themes, which are groups of co-occurring concepts, or sentiments, which are positive, negative, neutral, or could be more than that. I mean, today when you say NLP, people often think about text analytics and social media analytics tools, and that's where NLP is being used heavily. For instance, it's used to analyze emails and tweets and claim notes and so on. And so NLP algorithms are used over this text data and extracting out entities and concepts and sentiments and themes from the text, and then that data can be analyzed to understand the customer. And in fact, you may already be using it. And it can go further than that, though, to enable interfacing with systems using human language, like think about Siri or think about search-based BI that uses NLP to understand what you want to know. And these are things that are already out there on the market. So I think I've given you, machine learning that's being used today, natural language processing being used today. And then cognitive computing, which is a term that we've been hearing much more about. And different people define cognitive computing differently. So here we could take 2 of the components that we talked about already, machine learning systems that use data mining for pattern recognition, and natural language processing to provide assistance to humans and businesses. Another way to look at it is that cognitive computing solutions build on established concepts from things like natural language processing and ontologies, and leverage advances in big data management and analytics to complete focused types of tasks that seem to be sort of humanish. I mean, so for an example, a cognitive system could help you in an emergency room. So a cognitive system might be in a triage room. It could analyze your vitals and then correlate them with your medical and travel histories, and then predict with accuracy whether you have the flu or the Zika virus or some other illness. You know, this healthcare example illustrates that cognitive technologies sort of understand the world around us. They understand what's happening, but they focus on sort of they work in a highly focused context to complete a narrow but important task. So they're not replacing humans, they're interacting with humans. Our colleague Judith Hurwitz at Hurwitz and Associates just wrote a book on cognitive computing, which is an interesting read. And you know, she talks about the fact that cognitive solutions are suited to help when the domain is complex and conclusions depend on who is asking the question and the complexity of the data. You know, even though human experts might know an answer to a problem, they may not be aware of new data or new circumstances that would change the outcome of the inquiry. So a lot of this also has to do with automation, because we're dealing with lots of data and making lots of decisions. And then there's optimization, which is an enabling technology. And optimization is the process of choosing the action that results in the best outcome. So the actions that result in the best outcome. And typically there's three elements in optimization problems. There's decision variables that represent the decision or choices to you. If you're in manufacturing, it might be something related to production. There's an objective that you're trying to achieve. You know, maybe you're trying to minimize the raw materials that you're using. And then there are these constraints that are rules that place limits on how you can pursue your objective. You know, maybe that's the materials that are available or the amount of budget that you have. But the point is that the purpose of optimization is to achieve the objective within the limits of the constraints, and we'll give you some examples of this. But you know, a very popular example that's out there in the market is what happens in the airline industry. You know, when you look online, the price changes all the time of a ticket, and that's because airlines are using optimization to sift through millions of flight itineraries to derive the optimal price of a ticket in any point in time to maximize their profits. So optimization is an enabling technology. And then there's decision management, which involves systems that automate and optimize repeatable and operational business decisions. So, you know, that works by embedding business rules and analytics, you know, like the machine learning that we were talking about, directly into operational processes and tactical business systems. So I'm embedding rules and I'm embedding models into these business systems. And some examples would include things like credit card approvals or car loan approvals or recommendations to customers. So decision management is helping to bring the decision to the point of the decision maker, or to automate the actual decision. And we're going to give you some examples of this. So three core technologies: machine learning, NLP, cognitive, enabled by some of these other techniques like optimization and decision management. So we're going to move on to Dave. You're going to talk about one of the first examples that can be used for this.